Hi friends, this is Motion in a Straight Line part 3 for the NEET 2023, and in this lecture we are going to see how to read the position versus time graph, the velocity versus time graph, and the acceleration versus time graph. So let's begin. So let's suppose that this is me and I wake up in the morning and I go for jogging. So let's suppose. So I go for jogging along this straight road starting from this point A till the point B, and I return from point B, and again I stop at point C, okay, to do something. So let's suppose to enjoy a cup of tea or something. So now let's consider this much part of my motion and let us see how does the position versus time graph for this much part of my motion looks like. So the graph will look something like this. Okay, so see, I'm starting at this point. So distance is covered. The displacement towards right is positive. Displacement towards left is negative. And I will call this point as an origin. And the time at which I'm starting, I will call it as t equals to 0. Okay, so considering all that, the graph will look something like this. Okay, so I'm starting at t equals to 0 at x equals to 0, and I will call it as x1, which is equal to what? A. Okay, and then I speed up. Okay, initially my speed will be 0, then I speed up, I accelerate, and I stop at this point B. So again I decelerate and I stop at this point B. So this much is the change in position, right? So B minus A is my change in position. And then the change in time is from here to here. So how do I find the velocity in this much part of the motion? So it will be the displacement divided by time, right? So if I consider I go from point A to B to the point C, then the displacement will be the distance between point A and C, right? So if this is x1, if this is x2, then it will be x2 minus x1, and the time difference, let's suppose it is t2 minus t1. Okay, so you get velocity like that. So velocity is displacement, which is change in position, which is change in position x2 minus x1 divided by t2 minus t1. Okay, and it is the slope of this line. Which line? So if I take the starting point and the end point of the motion, if I pick start point and end point of the motion on this graph, then I join those 2 points, I will get a straight line. Then my average velocity in that much time interval will be what? The slope of that line. So what is slope of a line? So if you consider this line, suppose this is position versus time graph. So on this line, I pick some points. So this is the point. This is x, the horizontal coordinate. Okay, not x. The time is horizontal coordinate, and x, the position, is vertical coordinate. So t1, x1 are the coordinates of this point. P, t2, x2 are the coordinates of this point, which is q, let's suppose. Okay, and there is another point, this one, t3, x3 are the coordinates of this point. Okay, of this point. So now, what is the slope of a line? So it is change in vertical coordinates. Okay, so final vertical coordinate, if I consider these 2 points, then it is x2 minus x1, which is this much distance divided by t2 minus t1, right? T2 minus t1. So this is t1 and this is t2. Okay, and this is x1, this is x2. So x2 minus x1 is this much distance, t2 minus t1 is this much distance. So if you see it in this triangle, it is what? It is opposite side divided by adjacent side. So if you think in terms of this angle, it will be equal to tan of theta, right? It is equal to tan of theta. So slope of a line is given by what? Let's suppose it makes an angle theta with the horizontal. Then tan of that angle gives you slope of a line. Okay. So now you can pick any 2 points on the line to find out its slope, right? So there is no need to, I mean, these 2 points will give you slope, but you can take this point too. Okay, so you can pick this point and this point. So x3 minus x2. Okay, you pick this point and this point. So x3 minus x2 divided by t3 minus t2 will give you slope of this line, right? You can equally pick this point and this point. So x3 minus x1 divided by t3 minus t1 will give you the slope of this line. Okay, so this is how we find out the slope of a line. Is it clear? Now let's consider the position versus time graph of some object. So suppose it looks like this, and I want to find out the velocity of this object from the beginning at t equals to 0 till this time. Okay, so what do? I will mark this point and point corresponding to this time, okay, on the graph. So it's here. Then I will join those 2 points. I get a straight line, and as we have just seen, the slope of that straight line will give us the velocity in that much time interval. Okay. After that, suppose I want to take velocity. I want to find out velocity from this time to this time. So what do? Again, I will mark this point and the point corresponding to this time on the graph. So I will draw a straight line from that start point to end point, and I will find out slope of that line. Okay, and it will give me the velocity. Then suppose I want to find out the velocity from t1 to t2 double prime. So again, I will repeat the same procedure. So if I repeat the same procedure, what do I get? I will get this line, and slope of this line will give me what? The velocity. So as you can see here, as the time interval decreases, what happens to this line? So this line whose slope gives you the velocity in a particular time interval, it comes closer and closer to the curve. Okay, earlier it was this line, then it was this line, and I'm sorry, next you get this line. So the line is approaching closer and closer to the curve. So now you can imagine, if time interval is made very very small, vanishingly small, okay, what happens to the line? So the line will become tangential to the curve. Okay, it is approaching closer and closer to the curve. If time interval is made very small, okay, such that you can't distinguish, okay, the difference between starting time and end time, it's very small, almost zero. Okay, so you are finding velocity in an instant. Then your line will be tangential to the curve. Okay, so let's suppose I want to find out velocity at this instant t2 prime. So the slope of the line, okay, the line whose slope will give me the velocity, it will be like this. It will be tangential to the curve, right? So it is known as the instantaneous velocity. The velocity that you find is known as the instantaneous velocity. How do we define that? The instantaneous velocity is defined like this. It is velocity in a particular instant. So the time interval is almost zero. Okay. So limit, we write it like this: limit delta t tends to 0, change in x divided by change in t. And the change in t is almost 0. Okay. Right? And it is known as the derivative of position with respect to time. Okay, it is known as the derivative of position with respect to the time. So derivative of position with respect to time gives you what? It gives you instantaneous velocity. After that, let's talk about the area under velocity versus time graphs. So for simplicity, let's consider a graph which looks like this. So here velocity is constant, and that's why the graph is parallel to the time axis. Okay, so the object is performing uniform motion, And let's consider some time interval. So this is my time interval from t1 to t2. Now, what is velocity? The velocity is change in position x2 minus x1. So that is position at time t2 minus position at time t1 divided by t2 minus t1. Okay. So if I take t2 minus t1 on left hand side, what do I get? V multiplied by t2 minus t1 is equal to x2 minus x1. And what does that represent on this graph? So now if you take t1, draw perpendicular on the graph, it meets at this point. If you consider time t2, from there you draw perpendicular, it meets at this point. So if you consider this region, the area under this region is V, length of this side, multiplied by length of this side. So length of this side is t2 minus t1. Okay, so let's call these points A, B, C, D. So area of this rectangle ABCD is, it is length of this side, which is equal to V, multiplied by length of this side, which is t2 minus t1. Okay, so this much distance is t2 minus t1. So V multiplied by t2 minus t1 will give you what? Area under this curve. And V multiplied by t2 minus t1 is what? It is change in position, final position minus initial position. That means it is the displacement. So from this we can conclude that the area under velocity versus time curve gives us displacement. Okay, so is that clear? So this curve is simple. Now in reality, the curve cannot be, curve can be like this also if the object is performing uniform motion. But if object is not performing uniform motion, it is performing non-uniform motion, so its velocity might increase and decrease, and anything can happen. Okay, so let's consider velocity versus time graph, which looks like this. Okay, which has got some heels and tails. So here again the area under this graph will give us what? The change in position, that is it will give us displacement. But question is how to find the area under this kind of a curve. So for that, what do? We break this total area into n number of small segments, okay, like this. So let's suppose we are starting at this time t1. So at this time velocity has some value, let's call it v1. Okay, and we consider small time intervals, so of length delta t, let's say. So we break down this total curve into n number of small segments like this. Okay, so if I consider velocity at this time t1, and if I multiply that with delta t, what do I get? So I will get approximately, I get the area under velocity versus time curve from this time to this time. So there will be some error. How much error? So actually I am taking velocity v1 and I am multiplying that with delta t. So it is equal to what? I'm sorry, it's equal to area under this rectangle. You can see here, it's area under this rectangle. Okay, so how much is the error here? So this much is the error. Area of this triangle, small triangle, it is the error. Similarly, this time will be t1 plus delta t, right? This is t1 and this much interval is delta t. So this time is t1 plus delta t. So velocity at this time is this much, it's this much, okay? And it is velocity at t1 plus delta t, you can say. Okay, if you can see this, it is velocity at t1 plus delta t. And now if I take that velocity and multiply it with delta t, what do I get? I will get area under this curve from here to here with this much error, with this much error, right? So similarly, okay, I do it for n such rectangles. What do I get? I will get area under the velocity versus time curve from time t1 till time t2 with some error, right? Now if we increase the number of segments, that means if we make the length of segments very small, what will happen? The error will get reduced. Okay, the error will get reduced. So now approximately we can say the displacement from this time t1 to t1 plus delta t is how much? It is v1 multiplied by delta t, right? So change in x is equal to what? V multiplied by delta t. And if we add all changes in x, okay, from the starting point till time t2, then we get this summation. So summation means we are adding this change in positions. Okay, so we are adding small displacements in those small segments of time. So if we do that, so now at the beginning here, the velocity is suppose v1, then the velocity will take various values, okay, at the different time intervals. Okay, so then at different time segments, I mean, so on right hand side you will have summation of I goes from 1 to n of vi delta t. Okay, so delta t is equal, right? We are dividing the total time interval in equal small segments, equal and small segments. So how many segments we have? We have n segments, so it is I. Okay, n segments, that's why we will take n such values. Okay, v1, v2, v3, so on and so forth. All right. So if we do that, we get what? The change in position. That is, we get displacement. And what is that? It is area under this curve with some error. And how do we reduce that error? So to reduce the error, what do? We take many segments. Okay. So ideally, the error will be zero if we take infinite such segments. Okay. So n tends to infinity means what? N is very large, very large. Okay, so in this limit, when n is very large, almost infinity, then this summation becomes an integration. Okay, it becomes an integration. It's written like this. So we get exact change in position, so we get exact displacement. Okay, that means we get the exact area under this curve if we divide the total area in infinite small segments. Okay, so error will be negligible, zero. All right, so change in position is given by what? It is integral of v dt from time t1 to t2. It's how we write it. Okay, and this integral symbol, it looks like s. Okay, if you see it, it looks like s. It is an elongated s, and it reminds you that you are doing nothing else but you are taking a sum, a large sum. Okay, fine. So what does this mean for this velocity versus time graph? It means the area under the velocity versus time graph. So area under velocity versus time graph gives you the displacement. Okay, displacement in a particular time interval, and mathematically that area is what? That area is the integral of v dt. So dt means the time is variable and it's changing from time t1 to t2. Okay, so t1 is known as the lower limit, t2 is known as the upper limit for this integration. Now I have made separate lectures on integration and other mathematical techniques. So if you don't know about them, please check those lectures. Okay. So next we'll consider the acceleration versus time graph, and similar to this case. So acceleration, we know it is what? It is change in velocity with respect to time. So if we consider this simple case, okay, simple case of uniform acceleration, that means acceleration is constant. So acceleration is constant, that's why the graph, the acceleration versus time graph looks like this. It is a horizontal straight line parallel to time axis. And if we consider time interval from t1 to t2, then you can see the area under this curve will give you what? It will give you change in velocity. How? So acceleration is change in velocity divided by change in time. So if you take this change in time on left hand side, what do you get? you get acceleration multiplied by t2 minus t1, and it is v2 minus v1. So in this graph, if you see, this is acceleration, this is t2 minus t1. So acceleration multiplied by t2 minus t1 will give you the area under this curve from time t1 to t2. So area under the acceleration versus time graph gives us what? It gives us change in velocity. Okay, so it's simple to find out area under this kind of a curve. But if we have acceleration versus time graph like this, what should we do? We should integrate. Okay, so v2 minus v1 in this case will be area under this curve from t1 to t2. But now we have to take integration of a with respect to time. So it is integration of a dt from time t1 to time t2. Okay, so the area under acceleration versus time graph gives us change in velocity, and mathematically it is integral of a dt from initial time t1 to final time t2. Okay, so this is simple. Now let's discuss some problems. So problem 1, which of the following curve does not represent motion in one dimension? So option A is like this is velocity versus time graph. Option B, velocity versus time graph, which looks like this. Option C is like this, and this is option D. Alright, so this is a simple question, and the answer is option B. How? So if you take some time, let's say for this time, let's call it something. Okay, suppose this is T1. You draw a perpendicular on velocity versus time graph. So it meets at these 2 points. So what does that mean? This object whose velocity versus time graph is represented by this curve, it has two velocities. Okay, this velocity and this velocity at this time. Okay, so v1, v2. So my question to you is, can an object have two velocities at the same time? The answer is no, right? So that's why this velocity versus time graph is not correct. So it cannot represent one dimensional motion, or for that matter any kind of motion. Okay, so the answer is option B, right? Next question. The displacement time graph of moving particle is shown below. The instantaneous velocity of the particle is negative at a point. So we have seen what is instantaneous velocity. So at any time, draw a tangent to the position versus time graph, and slope of that tangent will give you the instantaneous velocity. So we have these points, okay, these 4 points. So let's draw tangents at these 4 points. So 1, 2, 3, and 4. So you can see here this tangent is slanted upwards, that means the velocity is positive. This one is horizontal, that means at this point the velocity is 0. This one is slanted downwards, so at this point the velocity is negative, right? And that is what is asked in the question. So our answer is point E. Okay, this one is slanted upwards, so here also velocity is positive. Okay, so answer is point E. So E is in option A. So option A is the answer. Okay, simple. Next question. A particle shows distance time curve as given in this figure. The maximum instantaneous velocity of a particle is around the point. Which point? So again, let's draw tangents. So let's suppose these are the points 1, 2, 3, 4. Okay, so now let's draw tangents at these points. Okay, so for me, this tangent has the maximum slope, okay, the point, okay, for me, for my eyes, you can check this, okay, this one has the maximum slope, so the answer would be point C, okay, and it is option D. So option D is the answer. Simple. Next question. Next question is, two cars P and Q start from a point at the same time in straight line and their positions are represented by xp of t is at plus bt square and xq of t is ft minus t square. At what time do the cars have same velocity? At what time they will have same velocity? So we know what is velocity. Velocity is derivative of position with respect to time. So v of p is equal to v of q. Okay, that is derivative of xp with respect to t is derivative of at plus bt square is equal to derivative of ft minus t square. So now let's take the derivatives. So if you take derivative of this one, so a is a constant, it will go out and it is dt by dt. So dt by dt is 1. Okay, so we have a plus derivative of bt square, so b we can take out, and derivative of t square with respect to t. What's that? So we have this rule, derivative of t raised to n with respect to t is n t raised to n minus 1. Okay, so here n is equal to 2, right? N is equal to 2. So the derivative will be what? 2 times t raised to, okay, n is equal to 2. So 2 times t raised to 2 minus 1. 2 minus 1 is 1. Okay, so that is t. So 2t, and it's equal to, similarly on right hand side, I can say it is f minus 2t. Okay, and then you can take this 2t on left hand side. So you get b times 2t plus 2t is equal to f minus a, and then you can take t common on left hand side. So what's left? It is 2b plus 2, and take that on right hand side. So t is equal to f minus a divided by 2b plus 2. This is the answer. So option D is the answer. Okay, if you take 2 common, it is b plus 1 or 1 plus b. Okay, so this is the answer. Next question. If the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 seconds is. So we know what is distance traveled. It is area under velocity versus time curve, and mathematically it is the integral of velocity, okay, from a particular time to a particular time. Okay, so from initial to final time. So velocity is at plus bt square. You can write this as the derivative of position with respect to time is at plus bt square, and then you can write it in differential form. So I will write dx is equal to at plus bt square dt. Okay, you can say you are multiplying with dt on both sides, and then you take integral from 1 to 2. So time is changing from 1 second to 2 seconds. Okay, so position is changing, suppose from x1 to x2. So integral of dx will give you change in position. Okay, integral of dx is x. You put the upper limit, so x from x1 to x2, it's equal to this integral. So here a you can take outside, it is integral of p dt from 1 to 2, plus b you can take outside, it is integral of t square dt from 1 to 2. Okay, so here I have separated, okay, these two terms at and bt square. So it is integral of this thing dt plus integral of this thing bt square dt from initial to final limit 1 to 2. Okay, so this one, so now what do we have to do? So here it's x, substitute the upper limit, which is x2 minus the lower limit. Okay, whatever you get, you substitute upper limit, which is x2, minus you substitute lower limit in the same thing, same function. Okay, so it is x2 minus x1, and it's equal to a multiplied by what is the integral of t dt. So we have this rule, this formula. So integral of t raised to n dt, okay, from some limits, okay, it is equal to t raised to n plus 1 divided by n plus 1. Here n is equal to 1. Okay, it is t means it's t raised to 1. So its integral will be t raised to 2 divided by 2. T raised to 1 plus 1, 2 divided by 1 plus 1. Okay, because n is equal to 1. So t raised to 2 divided by 2 from 1 to 2, plus here you have t raised to 2. Its integral will be t raised to 3 divided by 3. T raised to 2 plus 1 upon 2 plus 1 from 1 to 2. And now you have to substitute the limits. So it is equal to, what is equal to x2 minus x1. The displacement is equal to a times this t square upon 2. 2 you can take out. So a by 2. So it is 2 square minus 1 square. So 1 square is 1, plus b by 3. Okay, so 3 you have taken out. It is t cube divided, sorry, t cube, which is 2 cube. 2 cube minus 1 cube is 1. Okay, so from here you get 4 minus 1, that's 3. 3 by 2 a, and from here you get 8 minus 1, that's 7. 7 by 3 b. So 3 by 2 a plus 7 by 3 b is the answer. So option A is the answer. Okay, the x in meter of a particle. So x is position of mass m in kg moving in one dimension under the action of a force. Okay, so this particle is moving in one dimension. It's under the action of some force. Is related to time in second by t equals to this equation. Okay, square root of x plus 3. The position of particle when its velocity is 0 will be. So this is the question. Okay, so first of all we have to convert this relation. So t is equal to square root of x plus 3 can be written as square root of x is equal to t minus 3, and then we can take square on both sides. So we get x is equal to square of t minus 3. Okay, after that we can find out its velocity. So in question they are asking when velocity is 0. Okay, so velocity is derivative of position with respect to time, it is derivative of position with respect to time, and it's given at some time it's equal to 0. But first of all let's find out the derivative. So you can take derivative of this directly, or you can expand it. So it will be t square minus 60 plus 9. Okay, and derivative of that. So what is derivative of this thing? So it is equal to derivative of t square with respect to t is 2t. 2t minus you have derivative of this thing. So minus 6. Okay, minus 6 you have taken out, dt by dt is 1. So 2t minus 6, and it's given at some time this is equal to 0. So then, so 2t minus 6 is equal to 0. That means 2t is equal to 6 and t equals to 3 seconds. And you are asked what is the position at this time. So put t equals to 3 seconds here. Okay, you got this formula for x. So put t equals to 3 here. So what do you get? So 3 minus 3 is 0. Okay, so the answer is 0. So answer is option B, 0 meters. Okay, next question. A particle moves along a straight line OX at a time t in seconds. The distance x in meters of a particle from O is given by x is equal to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? And the options are 16 meters, 24 meters, Okay, 40 meters and 56 meters. Okay, so object is coming to rest, right? Then that means its velocity will be equal to what? It will be equal to 0. So we have to find out velocity. Okay, so we know velocity is dx by dt. So it is equal to d by dt of 40 plus 12t minus t cube, and it's equal to the derivative of 40 with respect to t is 0, right? Derivative of a constant is 0. Constant does not change with respect to time. Then 12 you can take out. Then you have derivative of t with respect to t, which is 1. So it's 12 minus derivative of t cube. So we have this formula, t raised to n. Derivative of that with respect to t is equal to what? N, t raised to n minus 1. So here n is equal to 3. So substitute n equals to 3. We have 3 multiplied by t raised to 3 minus 1. 3 minus 1 is 2. Okay. So 3t square. So 12 minus 3t square. And this velocity is equal to what? So it is equal to 0. We have to find its position, the change in position from the beginning at t equals to 0 to t equals to when the velocity becomes 0. Okay, so the velocity is equal to 0. That means 3t square is equal to 12 and t square is equal to 12 divided by 3, which is 4. So t equals to 2 seconds. Okay, so how do we find the change in position? So it is final position minus the initial position. So we have got the formula, sorry, the time, okay, and the formula for position. So we can say x1 is equal to, okay, I can say x1 is equal to 40 plus 12 times 0, because initial time is 0, minus 0 cube. Okay, so that is 40, and x2 is equal to 40 plus 12 times 2, because the time when the velocity becomes 0 is 2 seconds. So 12 times 2 minus 2 cube. So this is equal to, okay, 40 plus 12 twos are 24 minus 2 cube is 8. Okay, so 24 minus 8 is 16. So 40 plus 16, 56. Right? So 56. This is x2. So what is displacement? How much is the distance covered? It is x2 minus x1. So 56 minus 40, that is 16. So 16 meters. 16 meters is the answer. Option A is the answer. Next question. The position x of a particle with respect to time t along x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t in seconds. What will be the position of this particle? What will be the position of this particle when it achieves maximum speed along positive x direction? So when it achieves maximum speed. Okay, so this is the question. So now what will happen when it achieves the maximum speed? The acceleration will be 0, right? Okay, it has achieved the maximum speed. So you know, till the time there is some positive acceleration, what will happen? The speed will keep on increasing. So only when the acceleration becomes 0, the speed will stop increasing, right? There will be no change in speed if acceleration is 0. So when the particle achieves maximum speed, its acceleration will be equal to 0. Okay, so we have to find at what time the acceleration becomes 0. So we are given x is equal to 9t square minus t cube. So if we take its derivative, okay, so v is equal to dx by dt, we know it's equal to d by dt of this thing 9t square minus t cube. So let's take the derivative. I will write it directly because we have taken derivatives like this before. So derivative of t square is 2 times t minus derivative of t cube is 3t square. Okay, so it is 18t minus 3t square. This is your velocity. And what will be acceleration? So acceleration this change in velocity with respect to time dv by dt. So it is d by dt of this thing 18t minus 3t square. So if you take the derivative, it is 18 minus 6t. Okay, so 3 times derivative of t square. Derivative of t square is 2. Okay, 2t. So 3 times 2t is 60. So 18 minus 60. This is your acceleration. And the acceleration is equal to 0. That means 6 times t is equal to 18. Okay, if I take this 6 times t on the other side, because acceleration is 0, so 6 times t is equal to 18. That means t is equal to what? 18 divided by 6. So it is 3 seconds. Okay, and the question is, what will be its position when it achieves the maximum speed? So we have to find the position at this time. So x is equal to 9 times p square, so 9 times 3 square minus 3 cube. So it is 3 square is 9, 9 times 9 is 81, 81 minus sorry, it is 3 cube, so it is 27. Okay, so the answer would be 54, right? So 54 meters is the answer. Okay, got it? Simple. Next question. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to this equation, where beta and n, this beta and this n, are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by, what would be the acceleration as a function of x? This is the question. So we are given velocity in terms of position, not in terms of time, and we are asked the acceleration as a function of x. So let's try to solve this. So you have velocity v of x is equal to beta x raised to minus 2n, and if you take its derivative d by dt of v with respect to time, you get d by dt of this thing with respect to time, but this is function of x, so that means you cannot directly take its derivative with respect to time. So what do you need to do? You need to use the chain rule. Okay, so if you don't know what is the chain rule, I will multiply and divide by dx. So d by dx of this thing beta x raised to minus 2n, so I have divided by dx, I will multiply by dx, so dx by dt. Okay, so now beta you can take out, it is derivative of x raised to 2n with respect to x, and we know the formula for that. So we get acceleration equals to, beta is out, so minus 2n multiplied by x raised to minus 2n minus 1. Okay, so here the power is minus 2n, so it comes in multiplication. Minus 2n multiplied by x raised to, power gets reduced by 1, minus 2n minus 1. Okay, multiplied by dx by dt. What is dx by dt? Dx by dt is velocity. Okay, and then we want it in terms of position only. So we know the velocity in terms of position is this. So let's substitute that back here. So we get it is equal to minus 2 times n beta x raised to minus 2n minus 1 multiplied by, what is velocity? It is beta multiplied by x raised to minus 2n. So this beta times beta gives me beta square. Okay, so acceleration is minus 2n beta square multiplied by x raised to minus 2n. Minus 2n is minus 4n minus 1. Minus 4n minus 1. So minus 4n minus 1. This is the answer. Minus 2n beta square x raised to minus 4n minus 1. So option D is the answer. Okay, simple question, right? Provided you know the chain rule. Okay, so then let's see this question. A particle moves a distance x in time t according to the equation. This is the equation. The acceleration of the particle is proportional to. Okay, so let's find out. So first of all, let's find out velocity. So dx by dt is equal to, this is t plus 5 raised to minus 1. So d by dt of that. So it is minus 1. Okay, the power will come in multiplication, minus 1 multiplied by t plus 5 raised to minus 1, that's minus 2. Okay, so what did I do? So it's d by dt of position. Velocity is dx by dt. And so this is my velocity. So acceleration is dv by dt. So it is equal to, now this minus 1 is there and you have to take derivative of this term. So it is minus 2 multiplied by t plus 5 raised to minus 3. Okay, so it is 2 times, it is 2 times t plus 5 raised to minus 3. And the question is, the acceleration is proportional to which of these things? So is it velocity raised to 3 by 2, or distance square, or distance raised to minus 2, or velocity raised to 2 by 3? So let's check. So first one, let us check, is it velocity raised to 3 by 2? So we have acceleration as t plus 5. It's proportional to t plus 5 raised to minus 3, and velocity is proportional to t plus 5 raised to minus 2. So let us adjust t plus 5 raised to minus 2 here. How can we do that? So I can write this as, this is 2 times t plus 5 raised to minus 2, okay, raised to minus 3 divided by 2, right? So I am multiplying and dividing this power with 2, okay, with minus 2 actually. Or I can take this minus sign inside, okay, because we already have minus 3. So I will take minus sign inside, okay. So I am multiplying and dividing with 2, okay. So see what you get. This is directly proportional to velocity, or in fact if I write this as minus 1 and here minus 1 negative sign, it will be velocity only. So this can be written as, so this is equal to, acceleration is equal to, what do I get? I get it as minus 2 multiplied by v raised to 3 by 2. Okay, so if I multiply this one and this one with minus 1, it is minus 1, t plus 5 raised to minus 2 is your velocity, raised to 3 by 2 gives you acceleration. That means the acceleration is directly proportional to v raised to 3 by 2. Option A itself. We don't need to check other options. So this is the answer. So I hope you understood how to solve the questions based upon derivatives and integrals from motion in a straight line. Keep solving questions. This is it for this lecture. Thanks for watching. See you in the next lecture.